Welcome to the first of several videos where we'll prove the properties of hyperbolic functions. In the introductory video, we defined each of the 6 hyperbolic functions as we see here. We also discussed how these functions, even though they're exponential functions, have similar properties to trig functions. The properties we're talking about are the properties given here. And notice if we look at these properties, or identities, they look very similar to some of the trig identities. In this video, we're going to focus on this first property, hyperbolic cosine squared x minus hyperbolic sine squared x equals 1. Notice how this looks very similar to the trig identity cosine squared x plus sine squared x equals 1, but notice for the hyperbolic function identity, we have a difference rather than a sum. So to prove this identity, we're going to write hyperbolic cosine squared x in exponential form, hyperbolic sine squared x in exponential form, then square the fractions, and then subtract the fractions, and then hopefully show the left side is equal to positive 1. So for hyperbolic cosine squared, we would have e to the x plus e to the negative x divided by 2 squared, and then minus hyperbolic sine squared, which would be e to the x minus e to the negative x divided by 2 squared. We want to show this is equal to positive 1. So now we'll go and square each fraction. Well, if we square the denominator, 2 squared is equal to 4. So for this first fraction, we'd have a denominator of 4, and then the numerator would be 2 factors of e to the x plus e to the negative x. And then we'll have minus. This fraction would have a denominator of 4 as well, and then we'd have 2 factors of e to the x minus e to the negative x in the numerator. Now we'll go ahead and multiply the numerators and combine like terms. And just to review, when multiplying and the bases are the same, we should remember that we will be adding the exponents. So when multiplying these binomials together, we'll have 4 products, 1, 2, 3, and 4. So e to the x times e to the x will be e to the power of x plus x, or 2x. There's that product. And then e to the x times e to the negative x would be e to the x plus negative x, which would be e to the 0, which is equal to 1, which will simplify in the next step. And then we have e to the negative x times e to the positive x. Again, that's going to be e to the 0. And then we have e to the negative x times e to the negative x, which would be plus e to the negative 2x, since negative x plus negative x is equal to negative 2x. Let's go ahead and put this in parentheses, and now we're going to subtract the second fraction, and again show this is equal to positive 1. So again, we'll have 4 products, 1, 2, 3, and 4. So again, e to the x times e to the x is e to the 2x. We'll be subtracting this entire product here. And then we have e to the x times negative e to the negative x, which would be minus e to the 0. Again, the 0 came from adding x and negative x. And then we have negative e to the negative x times e to the x. That'll be minus e to the 0. And then finally we have negative e to the negative x times negative e to the negative x, which would be positive or plus e to the negative 2x. Again, this negative 2x came from adding negative x and negative x. Now for this next step, we want to clear the parentheses, and then we can go ahead and combine the numerators because we have a common denominator. So we'll have a single fraction with a denominator of 4. And to clear the parentheses, we can think of distributing a 1 here, but since we have a minus here, we can think of distributing a negative 1 to clear the second set of parentheses. So we'd have e to the 2x. Remember, e to the 0 is equal to 1. This is actually 1 plus 1 or 2, and 1 times 2 is 2. And then we have plus e to the negative 2x. Then we'll have minus e to the 2x. Again, this is minus 1 minus 1, so this is actually minus 2 or negative 2. negative 1 times negative 2 becomes plus 2, and then we have minus e to the negative 2x. Some of these terms are opposites. E to the power of 2x minus e to the power of 2x would be 0, and so would e to the negative 2x minus e to the negative 2x. So we have 2 plus 2, which is 4. So we have 4 over 4 equals 1, and 4 over 4 equals 1. Therefore, we have our proof. We'll go ahead and stop here for this video. We'll go ahead and prove another identity involving hyperbolic functions in the next video. I hope you found this helpful.